skies smiling at me. Nothing but blue skies do I see. Bluebird.
6.4 is on application of linear programming. This is going to be a long video. I'm sorry, this is hard to get through quickly. So you're going to do the same thing you did yesterday, your last class, which was linear programming. But this time you have to come up with the constraints and the objective function yourself. You have to come up with the inequalities. Okay, so we're talking in the first question about a toy company that manufactures racing cars and sport utility vehicles. And then we have these three bullets here, and I'll get to that in a second. It says the company wants to know what combinations will result in the minimum and maximum costs and what the cost will be. So that's will be the objective function wherever it talks about cost. So if you read through the bullets, it says here it costs $8 to make a racing car and $12 to make a sport utility vehicle. And since that's what you're trying to maximum or minimize is cost, this tells you that this bottom bullet here is the objective function. That's what you're trying to maximize or minimize. Okay? How about these first two bullets? No more than 40 racing cars and no more than 60 sport utility vehicles can be made each day. And the company must make at least 70 vehicles. Do you see these are constraints? The company can't make as many or as few racing cars and sport utility vehicles as they want. There's some constraints on them, and these are the constraints. These are the rules they have to follow when they're making the cars and the SUVs and stuff. Okay, so we have to come up with the inequalities based on these constraints. So let's do that first. Here's our constraints. No more than 40 racing cars. No more than 40 Oh, you know what we have to do first, actually? We have to come up with what are the two unknown things? Well, the two unknown things are racing cars and sport utility vehicles. So we need to call X and Y the number of racing cars, because that's what the question's all about, is how many do they want to make? So number of racing cars. And we'll call Y the number of SUVs. By the way, a lot of people call this R and S. I don't like to do that because you're going to eventually put it on a graph here, and usually we don't think of them as R and S axis, we call them X and Y axis, and that's why I always use X and Y. Okay, time for the inequalities. No more than 40 racing cars. Well, if X is the number of racing cars, and you can have no more than 40 of those racing cars, then X, the number of racing cars, has to be less than 40. Can't have more than 40. Can you have 40? Yeah, if you have no more than 40, you can actually have 40. It can be equal to 40. So it's less than or equal to 40. No more than 60 sport utility vehicles. Sport utility vehicles are Y, so Y has to be less than 60. Can it be equal to 60? Yes, it can. Less than or equal to. Next one. The company must make at least 70 vehicles or more in total. So in other words, if you take the number of racing cars and the number of SUVs, in other words, add together with that the number of SUVs, you need to have at least 70 vehicles. So in other words, the number has to be more than 70. Can it be equal to 70? Yeah, if I'm at least 35 years old, I'm definitely at least 35 years old, then could I be 35? Yeah, I could. I'm not, sadly, but I could be. So it can be equal to. X plus Y is greater than or equal to 70. Okay, these are our main constraints. There's actually two other constraints that come up all the time in questions like this. Do you remember what it is? What can X and Y not be? What kind of numbers when we're talking about racing cars and SUVs? They can't be negative. So X has to be greater than 0. Can it be 0? Can you have 0 racing cars? Yeah, you could have 0. So equal to is fine. And Y has to be greater than or equal to 0. All right, let's start by looking at these two constraints right here. What did those tell you, since X has to be positive and Y has to be positive? We talked about this before. That means when we graph it, the only part we really need to worry about is the first quadrant right here. And that's why when I drew my graph down here, I just did the axes to make the first quadrant. Okay, so you might want to do that in yours right now. Okay, so we're left with graphing these three constraints. Before we do that, let's look for the objective function, see if we can figure out what the objective function would be. We said it's right here. It costs $8 to make a racing car and $12 to make a sport utility vehicle. So if it costs $8 to make a racing car, how much would it cost to make 10 racing cars? $80, 8 times 10. How much to make 100 racing cars? 8 times 100. How much to make X racing cars? 8 times X, which is 8X. How much, it's $12 to make a sport utility vehicle. So how much does it cost to make an unknown number of SUVs, y number of SUVs? 12y. And what we want to know is we want to know the total cost. So if we add these together, we want to know what that cost is. So this is our objective function. The cost is equal to 8 times the number of racing cars, because every racing car costs $8, plus 12 times the number of SUVs, because every SUV costs $12. And we want to look to see what the minimum and maximum cost is. Okay, so now we're going to graph the inequalities, but first I better get some numbers on my graph. So look what kind of numbers we have here. We have 40, 60, 70. So I don't need to have numbers like 1,000, but I also want to have numbers bigger than 8. Why don't I go up to about 100? I think I'll be definitely safe if I do that. So this is my x-axis, and we said that the x-axis the x was the number of racing cars. So down here you could label if you want. It's the number of racing cars. And I'm going to go up by 10 to make it fit, and I'll go all the way up to 100. And then on the y-axis, which is over here, this is the number of SUVs, and I'll also go up by 10. And again, I'll go up to 100, although I don't think I need to go that high. And this is the y-axis, and that's why it's the number of SUVs, because we said here y is number of SUVs. So I'm going to graph these. The first thing I'm going to do is I'm going to graph x is less than or equal to 40, and I've already written it here. Instead of graphing that, of course, what I actually graph is x equals 40. So x equals 40, what kind of line is that? It's a vertical line. Where are all the points that have x value of 40? Right here. So I want to put a vertical line right there. Great. Now the next one says y is less than or equal to 60, but we'll graph y equals 60. What kind of line is that? That's a horizontal line. Where's all the points that have a y value of 60? Right here. So I need to put a horizontal line right there, like that. Okay, let's just look at the shading of those two. It says x is less than or equal to 40, and y is less than or equal to 60. So all the x's are less than 40, so they're all over here, and all the y's are less than 60, so they're all down there. So the only part we really need to worry about is this little rectangle down the left-hand corner here. That's the only place where it could possibly be. But we have one more inequality to worry about. It's this x plus y, and we're going to graph x plus y equals 70. This is really easy to graph. It's in standard form, so I'm going to find x and y intercepts. And if I'm looking for the x-intercept, I put a 0 in for y. If there was a 0 here, I'm left with x equals 70. If I'm looking for the y-intercept, I put a 0 into x. If I put a 0 in there, I'm left with y equals 70. So my points are 70, 0, which is out here, and 0, 70, which is out there, and now I join them with a line. Great. We just have to do the shading now. We said so far we only had to worry about this rectangle. So we're left with two possible areas that it could be. It's either in this triangle here, this little triangle, or it's this bigger shape here. These are the only two places we could possibly have the feasible region. So we just need to figure out what side of this line we just drew, which side should we be shading. So let's use a test point. Let's use the origin. 0 plus 0 is greater than 70. True or not? No, that's not true. 0 is not greater than 70. So you don't want to shade the side that includes 0. You don't want to shade down here. You need to shade up here. So this is the region that we're interested in right here. That's the only region. That's the feasible region. Every point in there works. Every point in there satisfies every single one of these 5 constraints. But we're interested in the maximum and the minimum. And remember where we only have to look for maximum and minimum? The vertices. So thankfully they're all pretty points in this case. That won't always be the case, but they're all pretty points, and that's all we have to worry about. So let's make our little table. Point and value. And the 3 points are 40, 30, 10, 60, and 40, 60. And the objective function, which is right here, is c equals 8x plus 12y. I'll just write that down here. c equals 8x plus 12y. Okay, and we just start plugging stuff in. So for the first one, c equals 8 times 40, which is 320, plus 12 times 30, which is 360, which equals 680 total. Next one, 8 times 10 is 80. 12 times 60 is 720. If you add those together, you get 800. And the last one, 8 times 40 is 320. 12 times 60 is 720. If you add those together, you get 1040. Last step, just pick out the maximum and minimum. Well, that's no problem. Here's the minimum up here, and here's the maximum down here. Okay, when do you get a minimum? You get a minimum of 680 when you make 40 in the X position. What's that? 40. X is racing cars. Remember, that's what we set up here. X is the number of racing cars. So if you make 40 racing cars and 30 SUVs, the total cost will be 680, which is minimum. If you make 40 racing cars, hey, it's the same number, it's interesting, and 60 SUVs, you will make the maximum, you'll have that maximum cost, which is $1,040. Okay, there you go. Okay, here's the second question. I told you these were long. I don't think I'm going to get under 20 minutes today. Ribbon flowers and crepe paper rosettes are being made as decorations. I have no idea what a rosette is. At least 50 ribbon, blah, 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 blah. Okay, so what are we doing here? We want to maximize or minimize what? What combination of ribbons and flowers will take the least amount of time? We want to minimize time. So one of these bullets must talk about time. Yes, I see time here. So this is where I'm going to get my objective function. The objective function. So these ones must be the constraints right here. Let's do the objective function first. Well, first of all, we should do our x equals and y equals. What are the two things we're talking about? We're talking about ribbon flowers, so we'll say x equals ribbon flowers. You could say y equals ribbon flowers, doesn't matter the order you do these in. And y equals the rosettes, the number of rosettes. Okay, our objective function. We want to, we're talking about time here. So time equals, each ribbon takes 6 minutes. So if you made 10 ribbons, it would be 6 times 10, which is 60 minutes. We have an unknown number of ribbons called x, so it would be 6x. It takes 9 minutes for each rosette, so we have an unknown number of rosettes, it's going to be 9y. And if you add them together, you get the total amount of time. Okay, for the constraints, at least 50 ribbon flowers and no more than 75 rosettes are needed. So there's two things there. The first thing is at least 50 ribbon flowers. So number of ribbon flowers is x, and there's at least 50 of them. So again, if there's at least 50 of them, then x has to be greater than or equal to 50. Next, it says there's no more than 75 rosettes. So the number of rosettes is y, and it says there can be no more than 75. So it has to be less than 75. Or could it be equal to 75? Yeah, it could also be equal to, so less than or equal to 75. Altogether, so both of them together, the x and the y, if we add both of those together, we can have no more than 140, so it has to be less than or equal to 140. Okay, so, and what are the other two constraints that almost always are there? X has to be greater than or equal to 0, y has to be greater than or equal to 0, because we're talking about ribbon flowers and rosettes, and those can't be negative. I don't even know what a rosette is, but I assume it can't be negative. Okay, so we're going to set up our graph here. Put some axes and some numbers. I'm going to stop the video and do that now. My numbers, as you can see, 50, 75, 140, so I need to go up to as high as about 140, so I'll do that now. Okay, I've done that. You can see I went up by 10s that fit perfectly to 140 on both axes. This is the y-axis, and so that means it's the number of rosettes, which I wrote here, and the x-axis should be the number of ribbon flowers, which I wrote there. Okay, that already deals with, since I'm only using the first quadrant, that already deals with these two inequalities, so now I have to do these ones. So the first one is x is greater than or equal to 50. So I think of x equals 50, and it'll just be a vertical line right at 50, like this. And then the next one is y is less than or equal to 75. So I'm going to put a line just where all the points that have y of 75, which would be right here. Now, if we look at the graphing, the x's have to be bigger than 50, so that means it'd be the right-hand side of this vertical line, and the y's have to be less than 75, so that'd be below the horizontal line. So the area we're actually interested in so far is this big rectangle down here. This is the only area that works. Okay, so we'll keep that in mind, but we still have one more to graph, and that is this: x plus y is less than or equal to 140. Think of that being equal. I mean, I guess I can rewrite it here, equals 140. This would be very easy to do standard form again, because if you put 0 into the x, you get 140 for y. If you put 0 into the y, you get 140 for x. So one point is going to be here at 0, 140, and the other point is going to be here at 140, 0, and then we'll join those with a line. like this. So there's a line. My graph's too big. It's hard to see the whole. Can't see the whole thing at once. Anyway, remember we still have to do a little more graphing. X plus y is less than or equal to 140. If we do our test point and put the 0, 0, the origin in here, 0 plus 0 is less than 140. True? Yes. So we have to shade on the side that includes the origin. We have to shade down here. Now remember, we were saying that so far we were down to just this region, but now it will only be in this region down here. So there we go. This is the region we're interested in. All these points work. They meet all the constraints. But of course, the only ones we actually have to check are these 4 points right here, the vertices. So let's write those down. We have point, and we have value. And the points we have are 50, 0. This is 140, 0. This one up here is at 50, and remember this line was at 75, so 50, 75. Now this last point, we know the y value is 75, but we don't totally know the x value. You can probably guess it's 65, but what if we didn't know? Okay, this will happen sometimes where lines cross and you have a vertex and you don't know where the point is. So here's where you have to use your systems of equations. What was the equation of this horizontal line? That horizontal line was y equals 75, right? When we graphed y equals 75, we got that. What was the equation of this line? That was the last one we did. That was that x plus y equals 140. X plus y equals 140. So what you have to do is you have to think of this as a system of equations and ask yourself, what's the solution to this system of equations? Because wherever the solution is, that's where the lines cross. Well, the easiest way to solve this one would be by substitution, because you already know that y is equal to 75. We can just plug that 75 into the y there. So x plus 75 equals 140, and then you'd solve by subtracting 75 from both sides. You get x equals 65. Now if you want to know what y is, you'd plug, well, you don't need to plug back in because you can see right there that y equals 75. So the answer to the system of equation is 65, 75, and that's exactly what point that is right there, is 65, 75. So this was an easy one, but some of them were not easy at all. It's hard to tell what the point is, and you'll have to use your system of equations work that you did earlier to solve those. Okay, but we know now that it's 65, 75. Last thing, we're going to plug those into the objective function, which is t equals 6x plus 9y. So I'll write that here, t equals 6x plus 9y. Alright, here we go. For the first one, 6 times 50 is 300, plus 9 times 0 is 0, so we get 300. The second one, 6 times 140 is 840. 9 times 0 is 0, so we get 840. That's a 4. The next one, 6 times 50 is 300. 9 times 75 is 675. So that gives us a total of 975. And the last one, 6 times 65 is 390. 9 times 75 is 675. If we add those together, you get 1065. And the question, if we look back here, is which one takes the least amount of time? We want to minimize time. So the least is this one. This is the minimum. So the minimum is 300 minutes, or if you want, 5 hours, right? Divide by 60. And when do you get that? When you have 50 in the x. What was x? If we look here, 50 ribbon flowers, 50 flowers, and, oh, interesting, 0 rosettes. So if your whole goal for your company is to minimize time, you should stop making rosettes. And you know what? I recommend that anyway, because I don't even know what a rosette is. Okay, we've made it at last. You won't have to do many of these questions for homework because each one of them takes so long. Take care.
I never saw the sun shining so bright, never saw things going so right. Noticing the days hurrying by, when you're in love, my how they fly by. Blue days, all of them gone, nothing but blue skies from now on.